Hello, my name is Blake Dittmer. My teammates' names are Jordan Kramer, Raven Doherty, and Eric Welch, and we are the Gatekeepers. So, to start out, our project was with AT&T, and our clients were Drew Walters, Steve Wilkerson, Michael Beaver, Matt McEwen, and Alex Bailey. Although we had multiple clients we could reach out to, we were mainly in communication with Drew Walters. He hosted our weekly meetings on WebEx, which was a 30-minute um, online video chat that we could ask questions and go over whatever we needed to that week. Start out with Zuul Gating, which is the heart of our project. The airship platform is a fully open source ecosystem that is quickly growing. As the project grows and more individuals begin to contribute, the need for more fully automated continuous integration gates become necessary. This is where our project comes in of Zuul Gating. Zuul is a program that drives continuous integration, delivery, and deployment systems with a focus on project gating and interrelated projects. We are using Zuul to replace Jenkins and the Airship repository, which leads us to pipelines. Zuul's configuration is organized around the concept of a pipeline. Pipelines have a set of instructions or triggers which describe how an event should be enqueued into a pipeline. Once this patch set is uploaded onto Garrett, the jobs of this pipeline will all run, and you can see their status, how long they took to run, etc. So back in August, we were given initial project goals of what we were going to try to do. The first is stage one, which is linting of YAML and bash files. The YAML and bash files are not linted before merging into Airship's repositories. So why would we do this? The goal of linting these files before merging is to identify syntactical errors. The other main goal of this is to promote consistency across the Airship repositories. For example, to make things easier to read or find things in files, we could simply set a standard for line length and spacing. We can do trailing spaces. We can make all sorts of rules so that every file is the exact same and it has to pass a set of guidelines to be merged into the repository. Stage 2 was password rotation testing, which consisted of triggering to change passphrases, changing passphrases of Airship services, and it was due to a lack of continuous integration. Password rotation, or the ability to change the passphrases of Airship services living in these clusters, is a critical feature lacking in the continuous integration checks. To do so, for instance, the treasure map secrets drive Shipyard to update its software. Treasure map and Shipyard are two of the repositories in Airship. And this software update happens, we can trigger it to change the password living in these files. Stage 3, upstream hosting of packaged Airship charts. These charts consist of Helm charts, push to repository, and developer benefits. Continuous integration checks exist to validate the packaging process. These artifacts are simply destroyed after creation. The developer would benefit greatly from this because as of right now they have to completely clone the repo to find this information they need, versus if it was just sent as an artifact to upstream developers. So the stretch goal for the project was to deploy a full Airship cloud app on AT&T's side of the T-Rex in downtown St. Louis. Airship's treasure map repository contains reference documents for deploying a full OpenStack cloud with Airship. All chart references currently point to Git repositories, but we could have simply changed these over to Helm chart repositories and deployed this. So what is airship? This image right here shows kind of the workflow of what airship is, but a deeper understanding of airship could be described as a collection of open source tools that declaratively automate cloud provisioning. Airship is a robust delivery mechanism for organizations who want to embrace containers as the new unit of infrastructure delivery at scale. Starting from raw bare metal infrastructure, Airship manages the full lifecycle of data center infrastructure to deliver a production-grade Kubernetes cluster with Helm-deployed artifacts, including OpenStack Helm. Airship allows operators to manage their infrastructure deployments and lifecycle through the declarative YAML documents that describe an Airship environment. So there's other things that do this. What separates Airship from other people? And that leads us to what makes Airship unique. First of all, declarative using YAML. The infrastructure is managed by YAML files using only one workflow for both deployments and updates. I know everybody likes things being simple, and this is exactly that. Also, jobs and services are resilient. The jobs and services are running on containers. They have status bars and can easily be healed by Kubernetes. So everything, if things break or things go wrong, we know what happens and it's easily fixed. Also, its components are loosely coupled, meaning all the components of the airship need to know very little of the other ones to fully function. This makes it easier to use all the technologies, especially if you have a lack of understanding.
I'll be talking about the languages and technologies we utilized while working with Airship. First of all, YAML. YAML is a markup language used to describe the Airship environment. We used YAML to set parameters for gates to follow, such as the maximum characters per line. We utilized Python to create scripts to execute the needed playbooks. We also used Ansible, a configuration management tool, in creating such playbooks. The playbooks are used to install the needed dependencies in each repository. As our project was done through the Linux command line, we became fluent with using bash commands to manipulate each repository. OpenStack. OpenStack is a free and open source software platform used for cloud computing. Garrett. Garrett is a web-based team code collaboration tool that we use to communicate with both our clients and the other members of the open source community. VirtualBox VM. VirtualBox VM is an open source software that allows us to emulate an operating system on each of our devices. This allows all members of the team to be in the same developing environment while on different operating systems. Ubuntu. Ubuntu is the operating system of our virtual machine. Zuul. Zuul is a gating system that ensures changes that are merged into their respective Git repositories are only merged if they pass predefined test jobs. Here we can see an example of some of the gates currently running through Zuul. We can also see a couple different indicators of how each gate is running. If we look to the left here, we see a red sliver. This red little sliver means that this gate failed. This blue little sliver means that this gate is still running. The green sliver means that these multiple gates have passed. And if we look over here on the right, we can see that how long this gate has been running. So far, this particular gate has been running for 5 hours and 33 minutes. If we look above it, we can see that the elapsed time, that the remaining time, is 1 hour and 49 minutes. So this one still has a bit to go. To the left, we have an example of one of the many patch sets we created. Every time we commit, another patch set is added with our new changes. This allows community members to comment and make suggestions on the code created with the new patch set. We can also look at previous patch sets to see how certain changes affected each repository. To the right, we have an example of the Garrett approvals. After committing our changes, the new code is ran through all active Zuul gates. If the gate passes Zuul, returns A+1. After the gates have been passed, code reviewers review the code and suggest changes. If the code meets their standards, the reviewers give the code a +2 to be merged into the active repository. Once additions have been added To the active repository, workflow is given a +1, and the rest of the open source community can now use the new functionality. To the right, we have an example of our MOS repository that we added our YAML linting gate. At the top, we can see that the code review was given a +2 by Drew Walters and Roman. This is saying that they approved our code to be merged into the workflow. Underneath that, we can see that it was verified by Zuul, basically saying that it has passed all the gates that we created, as well as the existing gates already in the repository. We can also see that it was given a +1 for our workflow, which means that it is now available for other users of the open source community to use.
So diving right into YAML linting, this is sort of how we went about setting up our project. So in each repository there are playbooks, and inside these playbooks is where we installed all of the scripts that we needed to go about installing YAML lint. And the two scripts that we opted to go with is the first script, which was to install YAML lint onto the repository, and then the second one, which was to actually execute the script and make it go into effect. And then from there, when we execute our YAML lint script, it is ran through a configuration file that we created. And what that allows us to do is it allows us to sort of make it our own. And what we did is we went with the open source community's kind of standards for what they wanted in to be linted, what were the rules, what was an error, what's a warning, in each specific repository. And then at the end is we have these amended job files, and with those is each of our YAML linting scripts, they get put into Zuul, and there's one check whether or not somebody passes the YAML lint gate or whether or not they fail. And to make sure, what users or developers want to do is they have to pass our gate in order to push their code into it being developed. And so without diving too far into the code itself, I'm just going to go ahead and give you a look at an example of a configuration file that we used in one of the repositories. And so as you can see on the far left here, there is so many different possibilities that you can change, whether it be from whether you want people to be able to use braces, brackets, whether it should air out on that, how long lines should be, whether people can have hyphens, and like what are the file extension names. There's so many. And so on the right is just a little snippet of an example of what we did, and say like one of the repositories, usually when you would run YAML linting, you would get an error if any line is over length, say 80 for example. And typically the open source community decided that 80 was a good approximate length for lines. So what we did is we sort of went in there and decided like, okay, we want line lengths to be around 80, but it's not gonna be the end of the world if it is, because some scripts, they have to be a little bit over that, and that's okay. And so we just opted to go with a warning for that route, so it wouldn't put any errors into the developers. And moving on, before we started linting, this is sort of the whole reason why this had to be put into effect, is if you'd go into any of the repositories, and in this example here we're using Treasure Map, which is part of the Airship project, and you'd go in here, you run the YAML lint command, and my oh my, you get so many errors. This is just a tiny bit of a snippet of the amount of errors. Treasure Map was probably one of our largest. There's hundreds of these errors, and it's just because all these developers have been pushing in their code over the past years, and nothing's really been in place to check that there's anything going on to limit them from having, say, bad code from being pushed in, right? Because if you can see here at the top in the Zuul YAML file, there's a line that's 407 characters long, and that's honestly just crazy, right? And so looking at this, is there's something that has to be put into a place to help counteract this. And so after adding in the code that we did into each of our respective repositories, this is the output that is now happening. And so as you can see, we got rid of all of the errors and we got it knocked down just to warnings, because there'd either be errors, warnings, or you're good to go. And warnings are things that could be changed, but it's not too crazy if they're still left in there. As you can see in some of these, it's not near like 407 characters. Usually, I see the highest here is 116. So usually it's nothing too bad. We went in specifically to several repositories, several files, and cleaned up some of the code ourselves just so it could pass our gate in Zuul. And from here, a lot of the repositories are looking a lot better. And all of our code we each were given one repository in the beginning just to kind of start from, and those 4 specific repositories are officially merged in to the open source community. And so they're out there, they're already doing work, and we've received good feedback that these things are working and operational. And we actually had a little bit of extra time in this first part of our project, and we were able to get another repository going as well. And so that is just waiting to be merged in right now. And so I'm going to pass it along to Eric to go ahead and talk about password rotation.
I'm going to talk about password rotation. It is an automated gate like YAML linting, but it does something completely different. So the password rotation gate is meant to cover more of a security aspect than a specific coding style aspect that YAML linting covered. So basically what this does is that it will ensure that passwords can be rotated, and it runs for every patch set that gets submitted. So this is a huge open source project, and tons of people are submitting different patch sets at all hours, day and night. And you want to ensure that everything that gets pushed in and eventually merged into Airship doesn't inhibit the ability to change passwords, assuming that there is some sort of security breach. You want to ensure that you're able to still be able to rotate and change passwords, whether it's just time to rotate passwords for general security concerns, or if there's been a security breach and you need to change them. And this gate basically ensures that anything that goes through and eventually gets merged in, that it doesn't impede the ability to change those. And the way that it actually works, it's a 3-step process. The first step is the gate would actually deploy and simulate a Kubernetes cluster, which would be what would happen whenever Airship is supposed to be run. It would deploy as a set of Kubernetes. Once the cluster has actually been successfully deployed, after that, you're going to run Helm on top of it. Helm is a package manager that is used to define, store, and manage server-side applications. In this case, it would be managing Airship. And then the final step, it would actually update a particular file in the deckhand repo, which is the values.yaml file that would contain in this case, a dummy password. And it's just checking to make sure that that password can be changed. So whenever it's populated with real values, it would still be able to change those. And then it runs it as a Helm upgrade, which is almost like a reinstall of Helm to ensure that the password replacement took place and that it's actually still possible to rotate passwords. If it passes, that means that there's nothing in the particular patch set that's being run that impedes password rotation. If it fails, something in there isn't allowing the values.yaml file to be updated, and that could cause potential security concerns if it's merged in and no one is able to change those files. So moving on to encountered problems. One of the biggest things was the learning curve. Whenever we started this project, none of us really had any idea about the specific tools and software that we would be using. So a big portion of what we did for this project was just learning about all the different tools and services that we need to be able to learn about the project and then be able to implement the project. A lot of the services were just completely unknown to us, so a lot of it was just asking our client specific questions and then looking online to see what we could learn about it. Another one of the things that we had to encounter was modifying existing files to pass new tests. So whenever we were doing the YAML linting gate, we had to change certain things about the deckhand repo files to make sure that they would be able to pass the deckhand YAML linting gate itself. So we actually had to do some manual linting of files to actually get the YAML linting gate to run in our own repos. So some of us had more linting work to do than others, but it was still something that kind of took a large amount of time and kind of took us by surprise. Something else, and this is just due to the nature of it being an open source project, but we encountered issues with certain repos. So sometimes it would be the case, and I know this happened with my deckhand repo personally, that other people would be working on it or merge things in while I was doing work on it myself. So whenever I would try to run and pass it in, my repo would be out of date. So I would have to like re-pull down the repo, or it would be the case sometimes of I would have something and it would work and it would pass a lot of the gates themselves that are running through Zuul, and then someone else would merge or change something and then break most of the gates that were working for me. So some of it was just a little bit of patience as certain things would be changed and moved around. And again, this is an open source project, so anybody could be trying and attempting to submit things at any given time. So it was very fluid with what would be working and what wouldn't be working. Another thing that we had to do for at least our YAML linting gate is we had to ignore certain chart directories. So certain things weren't meant to be linted just because they were used for templating purposes. And it would be the case that we reached a hang up to where a large amount of YAML linting errors would be present in the templates, but almost everything in the template would be replaced whenever Airship was actually deployed. So it didn't matter a whole lot that that wasn't specifically linted, just because it was all going to be replaced anyways. And then the final problem we encountered was passing code reviews. So to actually be merged into the Airship project, we would have to get a +2. So a +1 from two different developers on the Airship project, and just because of everything that goes on at AT&T, finding developers who have time to actually go through our code and review it and give it the +1 so we could finally get merged in sometimes was an issue, because there were people that would sometimes have a gate done and they would have to wait a little bit just to try to get more than one person on the Airship team to approve it so it could actually be merged in. So moving on to the retrospective. Looking back, we definitely underestimated the complexity. What we thought we were doing in the first week and the second week changed dramatically. It was the case that sometimes we would have meetings with our client, and everything that we had thought and looked up and we were sure that we knew, or we were sure we knew what was going to happen next, would be thrown out the window as our understanding evolved. So it just became more and more complex, and other issues would show up, and our client was very forthcoming and very helpful with all of those issues, but nonetheless the complexity was still there. So that was definitely a major challenge for us to try to overcome, just understanding the problem space and how to implement things in the problem space, because we almost weren't even really doing traditional coding in a sense. This was still a valuable learning opportunity. I know this was my first open source project, so this definitely showed me a lot more about working in that kind of environment. And the idea of working on a project so big that sometimes you almost have to worry about stepping on other people's toes, or like things that would change far beyond the scope of what you were necessarily doing, but because the nature of what you were working on was so big, it would sometimes create problems in like far-reaching aspects, far and far away from what you were doing, but you still had to try to find a way to deal with that and keep moving forward. We also definitely gained some valuable experience working as a team, being able to schedule team meetings, dividing up labor, sharing different information, because we divided up the labor fairly evenly by everyone working and doing the same thing in different repos, but we were also doing enough of the same thing that anytime someone made a particular discovery, we could share it and help explain, so we could all try to like elevate each other in our own understanding and how our implementation works, just because we were all working on different repos that tackled a lot of different things. But for the most part, as far as YAML linting and password rotation is concerned, the way that they function, uh, by and large, was the same. And that brings us to the end of the presentation. If you have any questions, we would be happy to answer them.